Thanks, Pam, and thanks for allowing me to get myself invited to Google. Come here. And also thanks for using your laptop so people here don't have to look at my Flickr sticker. That was a joke. All right. Yeah, I'll talk to you about some of the recent research I've been doing that I think is actually pretty exciting and is going to affect everybody's lives as much as the web has affected our lives already. So this is kind of the standard view you have of the web, which is a collection of documents that are interlinked. And as all of you know, it was Google's breakthrough that revolutionized search on the web, is like realizing that connections between these documents, this piece of information, can actually add value to evaluation of document quality, content. But at the same time, in addition to web documents, there are also all these web users of documents. And until a few years ago, their opinions, their knowledge wasn't taken into account until a slew of new sites, Web 2.0 sites, social media sites, they have different names, came about. Things like Flickr and Wikipedia, Dig, and Twitter. And excuse me if I bring in your competition here. And what these sites allowed people to do is actually not just communicate, form a community, but also share their knowledge and opinions and expertise about data, lots of data. What all these sites have in common are the following things. Users contribute content, whether it's images or articles or news stories or bookmarks, well, any kind of content, multimedia content or plain text documents. But more importantly, users add metadata to content. Through their everyday activities, users are annotating the document with lots of extra information. They use tags. So these are tags are freely chosen keywords by users to describe the document, categorize documents. They have this. Okay, users actually they discuss content through either blogs or through comment sections on Flickr sites. And also users evaluate content, evaluate documents either actively or passively, like either voting by it or just viewing. So in addition to all of this, but wait, there's more, as they say, in addition to all of this, users create social networks. They add the other users as friends, and most of these sites allow very quick and easy interface to keep track of the friends' activities. And also, they're all very transparent. You can actually navigate the site through multiple ways, through links, and see what everybody else is doing, thinking, talking about, things like this. So my apologies again to the Picasa team for using Flickr as my kind of prototypical web social media site. But here's an example of a photo page on Flickr. This is a photo that some users submitted. Each link, actually each word here, more or less each word is a link to more information. So if you click on the name of the user who submitted it, you'll see their user's photo stream, all the images they have submitted. You can see this image this user categorized this image with descriptive tags. You probably can see it, but it says reflection, sky, water, pink, blue, things that describe this image. And if you click on any of these tags, you'll see all the other images that a particular user has tagged with this keyword, or all the other images, all the other users on Flickr have tagged with this keyword. You can also see the discussion about this image. You can also see how many people had viewed it. This image was viewed 283 times, and 22 people marked this image as a favorite. If you click on the user's profile, you will see actually the friends, the social network this person belongs to, all the photographers this particular user is watching, and you can see what groups they belong to, user joined. So you can see sky and clouds, beautiful clouds, the reflections of users' interests. And again, if you click on any of this is a link to the group. You can see all the group images on this particular in here. You can also examine what are the tags that the user has used to annotate his own images with. And this is a cloud view. So the bigger the tag, the more frequent this keyword is in the user's photo stream. So you can see nature, sky, and clouds. This is what the user had used. These are the terms chosen by this particular user. As here, there's explanation about tags in case I'm just going to assume you guys are not familiar with tags and over-explain everything. So tags are the keyword-based metadata added to content. Tags were originally introduced to help users organize and manage their own content in order to search for it more quickly and browse for it more quickly. And these are freely chosen. There's no dictionary or anything that dictates what words users should use. And you can also examine, for example, what other images that this particular user has liked of other photographers, and also tells you a lot about the person's interests. You can see this particular person is interested in flowers and birds and nature photography. But like I said, these are images that this particular user has chosen as the favorite. So I get all excited and I start talking about this, and people just say, well, what's the big deal? But I believe actually it is a big deal, because by exposing human activity, social web allows users to exploit the collective intelligence and opinions of others in order to solve not just their own problems, but solve also like many bigger problems. The social web facilitates new ways of interacting with information, what they call social information processing. And allows you to exploit collective effects like word of mouth amplification of good information, among many other collective effects too. And what I like also about it is it is amenable to mathematical quantitative analysis, so you can actually design optimal systems that uses collaborative work of many individual users. And as somebody who works in the field of artificial intelligence, I think it offers also a new challenge, and as well as a new data set for AI. And the challenge is to harness the power of collective intelligence to solve information processing problems. And I'm going to, in the rest of this talk, I'm going to show what kind of problems you can solve. I'm going to show you how you can use user-contributed metadata to solve a range of problems. For example, information discovery, document discovery, how do you personalize results of search to individual users? How do you find new content to recommend to users, so recommendation problem, as well as collaborative rating. If I have time, I'll talk about mathematical modeling of user collective behavior in the systems. All right, so this is my accomplishments of my children and my photography. I'm going to sneak in a few photographs of my own in here. So first topic I'm going to discuss is document information discovery. And the goal of information discovery is to automatically find resources. There's web services, web pages, any kind of online resource that provide the desired functionality. For example, you're interested in finding sources that provide information about current weather conditions, or that allow you to track a flight, or or allow you to geocode a particular address. And this is a good problem, but it's a little bit difficult. So I'm going to look at a simpler goal, which is to find resources that provide the same functionality as some example source. I'm going to call it the seed source. And I work actually within an information integration group, and within this information integration, or for example, that creates mashups. The problem is important because once some source can fail, but they want to be able to support the application as a whole, so you need to find alternate sources that provide the same functionality. And our approach will be to leverage user-contributed tags, the freely chosen keywords that users have categorized things, to discover new resources. And I'm going to use Delicious, social bookmarking site, for this reason. And Delicious, has anybody actually used Delicious here? Familiar with Delicious? Only a few. Okay, only like 1/5 of the population. So Delicious is a social bookmark sharing site. If you find some web page online that you like to bookmark for future reference, you don't just put it in your browsers folder. You actually save it to the site. And when you save it to the site, you can add descriptive keywords. So for example, there's this resource given by a URL, FlightCom, that tracks flights. It allows you a flight tracking source. And you can see individual user, for example, CS, Lawson came and added tags, travel sites, and airlines. This is when users save, they can describe the resource so that they can find it later when they go like, oh yeah, remember that flight tracking, so what was the URL to it? And they can quickly type in by the tags that they have put in and find it. And so different users add nodes, maybe something descriptive to describe it, and then Delicious displays this kind of the popular tags. So you can see that out of the 451 people that have tagged this particular site, or I shouldn't say site, web page, this particular URL, 234 annotated with travel, 169 with flight, 140 with tracking or flight tracking, airline. You see, actually, there are good kind of descriptive keywords that we can use. And if you click on each individual one, you'll see all the other documents that all the other users have tagged with this particular keyword. So you can actually see then, we can actually start now accumulating this large collection of documents that might be related to travel. Hold on a second, okay. And so we introduced we're going to use AI tool known as probabilistic modeling. And we introduced the described tagging process as a stochastic process. The user comes in. This is represented in the graphical form. So this variable represents a user. And this is a resource, a URL they want to tag. And there's some hidden variables that we can't observe, that like users' interest and resource topics. These are represented here as white circles. Users' interest and resource topics. And based on these hidden variables, a user chooses a set of tags that describe to annotate the resource with. And this is what we observe. The tags, we observe usernames, and we observe the URLs. And from this, we try to learn, using probabilistic modeling techniques, you learn what the hidden unobserved variables are. So some small set of topics that describe this set of resources. And so this is the model we express, and we train it using expectation maximization, which is a popular technique right now in AI, to learn what are the topics. And my student actually was very ambitious. He didn't look at just a single model. He investigated using other models. This is different ways of representing. So you have here hidden topic, hidden variable, which is a topic generating observations of users, tags, and resources. And you can train this. OK. And in order to train it, we need to collect a data set. And the data set we collected is starting from this. We had 3 seed resources, like flight.com, which provides flight information. We had Weather Underground, that is a kind of seed source for weather conditions, and geocode.us, which geocodes sites. And from this, we went to supply this URL to that site, to Delicious, retrieved the popular tags. For each popular tag, we retrieved all the other documents that have been tagged with the same tag. And so we accumulate large collections of documents. So for flight.com, for example, seed, we had 3,500 resources, which had 14,000 tags and that were annotated by 34 or more than 34,000 users. And so different for each data set. And gosh, I almost feel embarrassed to be talking to this audience and comparing our results to Google, but this is what you do. You can also think you can do the same functionality by typing URL into Google's, and then find similar pages, right, which will return to this. So here's how we do. And this is actually, for fairness, let's look at black bars, which say how many. Then we had the student manually evaluate whether the discovered resource was actually discovered based on topics, not based on tags, was actually relevant to the seed or not. And we told the student to use either if the resource provided same functionality, it marked in black, and if it contained a link to the resource that provides same functionality, it's in a gray bar. So this is the total number of resources that our system can access with the same functionality as the seed resource. And you can see for flight.com, this is our model, this is the other model. So our model could get like 27, 28 resources that had the same functionality, more than Google's, but I find similar pages that could return, 15, it returned like 25, out of them 8 are relevant, so forth. And there's actually not that much variability in performance of probabilistic models, but they all perform better in our analysis than, find similar pages algorithm. The best performance was in weather pages. We were able to find like 60, even among the top 100. We only looked at manual labeled the top 100 results that the model predicted, and out of them, like 60 were relevant to weather information, rather than like 5 or so that Google provided. Any questions about this part of the talk? Because so by exploiting tagging activities of many different users, we were able to identify sources that provided this functionality we were interested in. And actually, there's all kinds of interesting ways to extend this tagging work. For example, we want to learn something like a directory of services, a hierarchy of sources, or maybe concepts of sources that provide services about different things. For example, we noticed that lots of people tag flight tracker as travel. So they have a general category in mind. So it would be great if we could actually learn that under travel, there's things like flights that have booking or flight status information, and also under travel, you have hotels with different types of information. And I believe there's that much content that we can actually extract this kind of information from. All right. So next, I'm going to talk, unless, no question. OK. I'm going to talk about how to personalize search results. And here we're going to use Flickr again as a model. So as I said, Flickr allows users to tag their own images so they can later find them quickly and easily. And if you type, for example, a keyword, you can actually tag name. You can actually search by tags. And you can see all the images that people have tagged with a specific thing. So if you type beetle, for example, you'll find all the other images that users had tagged with beetle, and I'm ordering them by their interestingness. So these are actually good images that are labeled by beetle. And you can see, actually, if you can see, if this was bigger, you could see that half of these images are about bugs, and half of these images are of cars. And that's an example of an ambiguous query term. So the term beetle has different semantics, different meanings, insect to car model. Likewise, if you type tiger, you'll get 50,000 images. Some of them will be of the Panthera tigris, the scientific name for tiger. But many of them will be of house cats or sharks, like tiger sharks or tiger lilies, or even macOS 10 operating system. You'll see screenshots of that. Likewise, I'm a child photographer. So I started thinking about this problem because I typed newborn to see all the interesting newborn images. And I got newborn babies, fine, but I also got kittens and puppies and ducklings and foals and many other types of newborns that I wasn't so much interested in. In fact, we can actually go through and we can evaluate how many of the top 500 images are actually relevant to the query that your user has in mind, the first sense of the word. And for newborn, there's only, and I can do precision. Precision is basically how many of the retrieved documents are relevant to this. So how many of the fraction of the 500 that are relevant. So for newborn, only 82% of the documents are relevant to the baby sense of the, for query tiger, only 67% of the 500, top 500 were relevant to the one. And for beetle query, only fewer than half were relevant to that sense of the word.
So if you're looking at the top 500 images, you're searching for tiger, but tiger is your query. You can say that you have a precision of 0.67 for the first sense of the word. But the other senses of the word are still, in some sense, correct.
Then in what sense are they correct?
I mean, they are tigers. They are about tiger. Tiger is
sure.
an ambiguous query.
But to the user who's executing the query.
Absolutely. But how do you optimize your precision for the user who is giving?
That's what I'm giving a talk about. That's what I'm. But so, well, was there any other questions? No. Okay. So, but actually, Flickr contains a lot of knowledge about my tastes and preferences that I can optimize my searches for me. And what kind of information do they have? I've expressed, because I'm a kind of power user of Flickr. I've been involved in just posting in the community a long time. And I've actually built up social networks of other photographers. So I've expressed my taste and preference through the other people I've added as my contacts. I've actually said something about my taste and interest in photography through the tags I've used to annotate my own images with. And also through images I've marked as my favorite. If I had a network connection, I could show you all the images that I've added. And you could look at it and say, oh yeah, this person is interested in pictures of babies. Which I am. And through groups I joined. So and we are going to look actually we haven't had a chance to look at all of this. We're just going to look at personalizing by text and personalizing by contacts. How you can actually very simply improve search results by just filtering the results through this even simple information that you have. And actually personalizing by context is actually kind of trivial idea. Basically means you return search results and only show search results from photographers who are part of your social network. And if you do that, so this shows, like I've selected for each of these query terms, I selected 4 users who are who I knew were interested in, or suspected strongly they were interested in that sense of the word. I went and looked at their tags, their streams, and said, oh yeah, this person is interested in wildlife in a zoo, tigers, and this person is interested in babies. So I had these 4 users for each set. And you can see this is the size of how many contacts they have. Ranges from 800 to 60 or so. And now if you filter the search results just by that and look at what is now precision and recall of the top 500 results, you can see actually you get very high precision. This does a good job picking out only the images that will be relevant to the user. So identified for this user, 232 of the 500 were relevant and 0 were irrelevant. And so down even to problematic cases like beetle, you still had maybe 7 were relevant, 1 irrelevant, but still very high precision, meaning there were very few false positive results that the systems thought were about beetle bug, but were actually about beetle car or something else. But if you look carefully, actually, so precision is great, but recall is low. Few images actually come back through the search. So I thought, well, no problem. Rather than filtering by your first level, your friends, how about filtering by your friends and their friends' friends? So you actually enlarge the social network that you're filtering with. And actually, the social network blows up a lot. So you go from, if one level you have only 700 users, after you expand the social network to 2 levels, you have tens of thousands of users. So it actually, and you do get improved recall, which means how many of the 500 images were actually returned to you But precision does drop relative to filtering by first level contacts. Still, you get much higher precision than and recall than an unfiltered search. You get between 9 to 16% average improvement in precision. And improvement in precision, I think, is what you're interested in. There's so much information out there. You're best to filter throughout information as long as you're displaying only the relevant information to the user. All right. So, but that's again. So that's like I said, it's kind of a little trivial idea because it's very easy to filter. Yeah,
personalizing by your contacts. Have you thought about the idea that if you have a contact, that it means that you have very similar interests? So
yeah.
If I type in tiger, right, and my contact has lots of pictures of tigers, then maybe I could use that information about his or her preferences and apply them to me.
Well, that's what I'm saying. I'm kind of assuming this will motivate that people's contacts have similar taste to the user itself. Yeah, and it's actually borne out by the extremely high precision you actually get in there. But that's people generally add contacts, photographers whose work they like. There's many different reasons people add contacts. They want to keep track of friends and coworkers, but if they're going to add a stranger to their contact list, it's somebody whose work they like, But there's a lot of information in these links that we're actually going to do more work in these context links, favorites links, and so forth. But the second part, so in addition to contacts, or maybe instead of contacts, because kind of a very simplistic idea, but also I told you that users add tags to images. And they add titles, they add descriptions, they add images to groups. There are all this other textual information about the images with which we can exploit. And we can do similar to how I described this delicious work. We can build a probabilistic model that trains on a large set of images to find the hidden topics contained in the collection of images. So in Tiger, we want to find, well, this image is about wild animals. These are a set of images about house cats, and so forth. And then we can do the same thing. Given a user has a photo stream that has tags in it. So we can also find the topics that are of interest to the user. And then we can filter the search results and only present those that have similar on the topic that is of interest to the user. Okay? So again, we're going to have a model tagging as a stochastic process. So this plate corresponds to an image, has a user who created this image, and there's some hidden topics that the user is interested in. And based on these hidden topics, the user generates a set of tags that the user assigns to the particular image. And given a collection of many images with these tags, we can find what are the small set of topics, hidden topics that is. And here I'm actually showing you what. So we train on this 5,000 images from the Tiger query set. We'll run this algorithm, and with 10 topics, we have to set manually. Have to say, well, there's only 10 topics in here. And I'm showing you the highest probability tags within each of these topics. I'm only showing some of the 10 topics. So for example, topic 1 has tags like, this is the highest probability tags within these topics are tiger, zoo, animal, nature, animals, wild. So you start to see that these are tags associated with the wild animal, the first sense of the word tiger. Topic 2, for example, these are some group names actually, but also has flower, butterfly, macro, yellow, swallowtail, lily. So this is the tiger lily sense of the word tiger. This one is also very good actually. Cat, kitty, cute, kitten, cats, orange, eyes, tabby. This is all about house cats. So all the descriptive words that are associated with house cats. This one is also very good. Apple, Mac, OS 10, Macintosh screenshot. Mac OS 10 Tiger operating system. And here's a kind of catch-all. Not quite sure what the topic of this is, but that's what everything else that was not in those topics end up in this last topic.
How did you generate this again? How did you pick each of these topics?
No, we say we have this model, and we say there's K is 10. Mm-hmm. This is the only thing we fix. And then we run this, and it finds, what are the probabilities should be to divide this between 10 topics, That's it. All right.
Do you have weights associated with those?
With weights, with topics, yeah.
So when it does word lists?
Yeah, I'm showing you the top 25 highest probability. So there's actually probability with each of these in decreasing order. So this is the most. This is the first pass. The tiger occurs across all of them, which is it's not a very good tag because it occurs in every single image. So we shouldn't even include it. But it's promising. And actually, Flickr offers something like this kind of static that has clusters. They use some sort of clustering. We're doing something a little bit more sophisticated than pure clustering. OK, and so if you do the same thing now, if you take for this individual user and just show the results, the images that are on the same topics that the user was interested in tag space, here's the precision recall. And so then we rank the images, the 500 images, according to how relevant they are to the user. And then looking at top 50 of those images, how many of those are relevant and how many are irrelevant. So if you look at top 50, you get very high precision, 1.0, for example, for the newborn query, but lower recall, only per-cell recall. But the precision remains very high across it. If you now look at first top 200 images that are ranked by our method, and see how many of those are relevant and how many are irrelevant in the sense of the word, you can see actually precision stays relatively high. Recall actually gets up to 1/2, so it's pretty good. And now if you look at just our precisions defined, I told you out of the 500, there were 337 that were relevant to the query. So we look at the top 337 images and see how many of them are relevant and irrelevant. And precision recall for this one are equal. So you get 90%, you get actually 8 to 42% in improvement precision, which is pretty good. So filtering by tags actually, so yes, Flickr does contain enough. As long as I tag my images, it does contain enough information about my taste to do it like that. But there are actually other ways also. People who don't tag their images, and there are still lots and lots of people who do that, there are other ways to extract this information through the groups that they add images to, or other photographers who they favorite with. And I'd like to think of it as a very complex network of users connected to images, connected to tags. They're all interconnected. So there's many ways to get the same information out. All right. So I've showed you that actually you can improve results of image search for individual user. But again, as long as the user has expressed interest in this particular topic through in the topic of search somehow. But what if, for example, I'm interested in child photography, but I want to look at now landscape images? I'm not going to be able to use this approach because I haven't expressed anything about landscape images. But Flickr contains information about the structure of the network and connections among people too, so that I could be able to find the community of landscape photographers and who are the peaks, who are the good photographers within that community. There's a lot of that information there. That's next topic of research we're going to do. I should be probably telling you about next topics of research. But
another question.
Yeah.
Do you consider the source of the tag, if I was if I use a tag, then I'll mean something different. If I use the word tiger, I'm probably going to talk about Mac. Whereas if an animal researcher, so you could consider the tuplet of user tags.
So in Delicious model, here we didn't really have, because in Flickr, even though many different users can tag the same image, in general, just the image owner tags the image. But in the Delicious model, there was a possibility to have this user interest kind of, which could, we include both interest, user, allow for different senses, for different users having different senses of the same word. So we can actually change the model, probability model for that to allow for that.
Then likewise, there's expertise and trust issues. I'll trust my friend Leonard with music recommendations, but not philosophy.
So this is topic-based social networks, and you can actually add some sort of way to describe the links on social networks. That actually is, I don't think many people have looked into that at all, how to introduce semantics to the links of social networks, and that's something also we're interested in. All right, so next I'm actually going to, this was, research kind of started out with a question about social networks, and I'm going to show you how social networks can be used for recommendation. Here I'm going to introduce a yet new site called Dig. And it was a kind of media darling, but I think it's kind of maybe a little bit on the decline right now. But Dig is a social news aggregator, and it has a very simple premise. Users submit stories, so they submit links to stories they find online. And other users vote on them. They call them by digging them. So users vote on them, and then they kind of select out of the stories that had the most votes, selects few stories to feature on its front page. And when you go to dig.com, you see the front page. So you get a lot of exposure for this. And their claim to fame is that they have, rather than having a few editors deciding what should be the front page content, it emerges from the independent opinions of many users. So it's kind of an emergent front page concept. And also, Dig allows users to create social networks just like all the other sites. And they add friends, and they have users can add friends, designate others as friends, and then they have a friends interface that allows people to track the activity of friends. So this is actually a typical Dig page. It has stories, and here's the number of what story received. But if I'm a registered user and log into Dig, I'm going to also see the friends activity. By clicking here, I can see that 65 of my friends liked or voted on. There's 65 stories my friends have voted on, or in the past 2 days, or my friend submitted 11 stories in the past 2 days. And they can click on those links and only see those stories and no other stories.
So do you have a problem with the collaborative front page emerging from the opinions of many users and not a few editors then? In the sense that, like, at some point, people running the site decided the front page was no longer interesting, and they had to go in and, like, seriously mess with the procedures for deciding what appears on the front page because they didn't like what the users were selecting.
Well, I'm going to touch on it briefly. There was a controversy that came out in September, like, oh, there's a cabal of top users there, like, who dig in each other's stories automatically, and they're the ones who are controlling. In fact, I should just submit the paper yesterday, so this is fresh in my mind. I've looked at Dig behavior over a period of a year. It was interesting. There was first of all, as I'm going to show, there was no cabal. I mean, I don't know if there was cabal or not, but the same kind of findings can be explained by just social filtering that I'm going to talk about. And in any system, you have this Pareto principle, that 20% of the people do 80% of the work. So it's true. Top 3% of the top 1,000 users were responsible for 30% of the top stories. But it's true on any site. Wikipedia is the same way. Flickr is probably the same. Any site is that way. So people saw the statistics and they said, oh no, it's like top users there. It's not democratic if they have such disproportionate share. There was so much acrimony. You can see a spike in activity in September when the story came out, and then just drops. Just this acrimony alienated users so much that their activity, like now, the top users have just a small fraction, 1/10 as active as they were back then, even those who stuck around and did not leave as a result of this controversy. So it's important, if you're going to run a social media site, you should actually keep top users happy because they're the one doing most of the work. And if you alienate them, you're hardly going to recover. So I think the number of Dig users is growing, but I think people mostly coming, contributing one or two stories and then never going to the site again. So the core of users who kind of sustain the site is gone. And I know I can't evaluate the impact it had on the quality of the front page. I just know the impact it had on user activity, and definitely has gone down by quite a bit. All right, so as I said, Dig ranks users based on how many stories the users have promoted to the front page. And it used to be, they stopped making this list available. It used to be, you could go and you can see who's the number 1 user, who's number 2 user, and you can go through and you can actually scrape the site and find out what stories they dug, they liked, what stories they submitted, who are their friends, who are the other people who call them friends. You can extract the whole social network. You can get all kinds of statistics. How many stories this user submitted, how many stories were promoted, how many stories the user commented on. There's a lot of, like I said, I liked it because it was very transparent until actually recently. And also I should point out that social networks, actually, there's this asymmetry. When someone A designates B as a friend, A is watching B's activities, but not the reverse. So I actually call user who is watching the activities, A is the reverse friend of B, and B is the friend of A. And so, but also because it's so transparent, I was able to study actually literally weekly or even daily or hourly, can see how what's on the story changed, how the social network changed on a weekly basis. So I've tracked 2,800 stories submitted over a period of a day last May. And of these stories, I saw that 98 became popular. And then also I could see out of this, then I looked at another set of 200 front page stories, and I could see the names of everybody who voted on the story. Like I said, it's lovely how transparent it is because you get a lot of data like that. And so this graph shows how votes on stories change, on select stories in this data set change in time. And you can see basically they have very similar behavior. A story is submitted, then it spends some time in the upcoming stories section of the site, which very few people go and look at. And after it accumulates enough votes, it gets promoted to the front page, and then its number of votes, shoots up dramatically, then saturated some value. And you can see some saturated lower value, some saturated higher value, and so forth. And this saturated value, that the number of digs or what saturates at, I call it story interestingness. Obviously, it's higher, it's more interesting to general population of dig. And because I've been looking at this data set for such a long time, I knew the users by their first name basis, essentially. Notice that the top users were submitting stories that were kind of in the bottom here. And these users that were getting the most interesting stories were unknown or unranked users. And actually, you can do it even more kind of scientifically and do a scatter plot of the kind of the final number of votes received by a story versus the rank of the user. And the lower the rank, the more high ranked the user is, the more influential the user is. And you can see from this that this set is divided roughly in half, where 50 stories come from 14 users with average interestingness of 600, which is about, on this side you have half of the stories, interestingness about twice as much. So the lower ranked users were contributing more interesting stories here. So top users are not submitting the most interesting stories, so why are they so top? What makes them so top? And I think it's because social filtering explains why this is successful. Because users express their preferences through their social networks, and then they use these social networks through the Friends interface to filter the vast stream of new content that comes on Dig daily. And they only read stories, or generally just read stories that friends submit. So I'm going to analyze two claims, that users tend to like the stories their friends submit, and users tend to like the stories their friends like, because they can see both, see my stories my friends submitted and see the stories my friends dug. And this is just to show the social networks do exist on Dig. You can see the number of friends for top 1,000 users in one weekly data set. This is the number of friends they have versus the number of reverse friends they have, or users who are watching them. And the dark lines are the top 30 users. So you can see they generally have larger social networks. And this particular user was Kevin Rose, who's the founder of Dig. So he had, if you go, like when he explains how social network friends work on Dig, say, go ahead, add me as a friend. So people do. 20,000 people have added him as a friend, and they're watching him. So that's why he's all the way up there. All right, and this is how social filtering works. Suppose this user submits a story. The story becomes visible to all of his friends through the See the Stories My Friend Submitted interface. As these friends read the stories, it becomes visible to still more users through the See the Stories My Friends Dug part of the interface, and so on. It propagates through the network. So as more users read the story, it becomes visible to many more users through the social networks thing. All right, so here's the plot that shows I took 200 front page stories, and I looked at the names of all the users who dug the story, and I compared it to the social network of the submitter. And the blue line shows the size of the social network of the submitter, whose scale is given on this side. You can see that of these 200 stories, about half, more than half, were submitted by users who had substantial social networks, and half were submitted by unknown users. And the red line shows how many of the friends dug the story, how many of the submitter's friends dug the story. So you can see, and to get these numbers purely randomly by chance, if you just assume users vote purely by chance on the story, you can compute what the probability is. An average probability to observe this kind of numbers purely by chance is 0.5%. So this is not happening. It's highly unlikely to have happened by chance. And if it's not happening by chance, it's happening because users actually use the Friends interface to navigate Dig. And you can look the same. So this is the first part of the claim. So users tend to like the stories friends submit. Second part of the claim, users tend to like the stories the friends like. And here I looked at, OK, you have first person to dig on the stories, the submitter. Second, I look at the following people who vote on the story and look at their social networks and combine it. So this shows how the combined social network of the first user, combined social network of the first 6 users, combined session to vote on the story, and so forth, how it grows. And you can see as a story gets votes, it becomes visible to many more people. On this line, these lines are actually shifted upwards just so you could see them better. On this side, I'm showing how many of the users within this combined social network actually voted on a story. And you can see also this number grows. And you could do the same kind of analysis and see, well, after stories submitted by unknown users who had fewer than 20 friends, these are all the users who have 20 friends, to get that number of friends like voting a story, probability is 0.5%. After 5 more people vote on a story, the probability that the story had received that many digs from friends is 2%, about 3%. After 15 people dug the story, probability is about 6%. So it's getting to be less statistically significant, but it's still highly unlikely to get this. This is not happening by chance. People are actually using the friends interface to look through this. So TAPS users are responsible for a lion's share of front page stories for a reason. There's no wonder that 3% of top 1,000 users submitted 35% of front page stories. This can be explained purely by social filtering without involving any kind of conspiracy theories. It can be explained simply because top users tend to have bigger social networks and they tend to have more active social networks that spend a lot of time reading and digging stories. But like I was telling you before, this kind of similar finding resulted in controversy where top users were accused of being, colluding to automatically promote each other's stories, and they actually changed the promotion algorithm to count down, to weigh down the votes coming from friends. Complete opposite of the whole idea of how social networks. They wanted to have people actually using this through the social networks, and so the algorithm actually did lead to decrease the top user prominence on the front page. It worked for that reason, but might have had unintended consequences. It maybe discouraged users from joining social networks. Actually, here I show actually a similar analysis of interestingness of stories after the change in the algorithm was made. And you can see stories tend to be more interesting. First of all, only also looked at first 70 to 70 stories, and there's fewer duplicates of stories coming from the same user. Single users are less, top users is less likely to have multiple front page stories, only 36 from 24, rather than 50 stories from 14 users, and also tend to be more interesting. So 960 votes versus average votes versus 1,200. So it worked that, but it might have had unintended consequences like alienating top users, and actually I've seen that happening, or discouraging users from joining social networks. I've seen that happen too a little bit, but users had dropped users from their friends list after this. And so the question is actually, can we study this more systematically than just make a change in the algorithm and run it in the system and see what happens? And designing a collaborative rating system, or any collaborative rating system, which exploits the emergent behavior of many independent users is very difficult because small changes can lead to big consequences. Even the type of the promotion algorithm can affect what kind of front page you get emergent. And right now, there's very few tools that actually help people work this out. And rather than people can execute, that's what they do. They execute, see how the system runs over a period of 2 weeks, and then make tweaks and changes of that. And there's no way to explore the effects of these changes, design changes beforehand. And this is what I'm going to show you the first part of the last part of my talk, which is collaborative mathematical analysis of collaborative rating systems. Can we explore the effects of promotional algorithms before they implement it? And I claim actually you can use mathematical analysis to actually understand and predict the emergent behavior of these large-scale collective systems. And it can be useful investigating the choice of promotion algorithm you have and the effect of the promotion your design choices have on story timeliness, interestingness, user incentives to join social networks, and so forth. And then I create a very simple mathematical model that describes how what's on stories change in time. And this model is parameterized by just has parameter story interestingness. Basically, what is the probability a story will receive a vote if it's visible to some user? And its visibility actually only comes, it will receive a vote if it's visible. But what makes it visible? Well, it gets submitted, so it's visible on the upcoming stories pages. And as new stories are submitted, its visibility decreases because it gets pushed down farther to down list. It also is visible on the front pages, but as new stories are promoted, it gets pushed down. Its visibility decreases, and it gets pushed down to page 2, page 3, and so forth. And it's also visible through the friends interface, see the stories my friends submitted and see the stories my friends dug. And you can express all of this mathematically in this form. This is just interestingness and the visibility. And actually, all of these quantities I can determine from my previous data set. And there's only 2 parameters that characterize the behavior of the solutions of the systems of equations, which is the size of the submitter's social network, S, and the story interestingness, R. And every other parameter I can get from the data. So this shows, actually, this is the same, almost the same. It's like similar data to I showed you before. This is actual votes received by actual stories on Dig. And each story I plot by the social network size of the submitter of the story. So these stories were submitted by people who had only 5 friends. And these stories were, this story was submitted by people who had 100, 160 friends. And this plot shows basically solutions of the model for the same social network size but different values of R. And you can see that the stories submitted by these more highly connected people have only interestingness of 0.1 and 0.2, whereas stories submitted by less connected people have story interestingness of 0.8, and so higher interesting value. And you can explore it much more systematically, basically say what is the minimum social network size required to promote a story of a given interestingness to the front page. And it has this form. So if you have social network size of 2,000, your story has to be only 0.05% interestingness to be promoted. Whereas if you have very small social network, your story has to be very interesting in order to get promoted.
Random question. Did you do an analysis of how often heavily connected users vote versus how often non-heavily connected users vote?
Well, heavily connected, but you can look at the number of digs, just digs made by users. So yes, top users, they're responsible for like 30% of the digs as well. So they actually do a lot more digging than low-ranked users. Not connected, just like lower versus top-ranked users.
It's very likely that the top-rated, heavily clicked users are providing like the lion's shares of clicks that decide whether or not a story is interesting, regardless of whether or not they or someone else.
Sure, but they're also helping other users discover less interesting stories because they're doing a lot of the work. They're spending, some users were rumored to spend like 14 hours a day, like clicking and reading stories. So they're actually providing, they're providing a lot of benefit. They're providing a lot of work. They're like lifeblood of the site. And sure, they're responsible for decisions just because they're the ones who are doing the opinions. Yeah. And also, like the time that they make the story, to promote the story, actually, the more interesting the story is, the less time it takes to be promoted. We actually saw it in this data as well, actually. The more interesting the story, the faster it was promoted. Less interesting, the more time it took promoted. And you can also study for time it takes, for a given R interestingness and S for different types of promotion algorithms. Basically, you can study the effect of the promotion algorithm on story interestingness, on the timeliness, just before it is implemented. And which, they could have done it to see how to design the system better. And interestingness of time, well, I can just blaze through. This is very short. But also, like I said, Dig used to rank users by how successful they were in getting stories to the front page. So the user ranked number 1 had the most front page stories. And this shows how the rank evolves in time from last July to basically May of, February of this year. And you can see some users, actually, the user number 1 user actually managed to stay number 1. Another user came in like 500 and quickly, like submitting a lot of stuff and getting promoted, making friends and everything. He made his rank down to 2, and then he actually disappeared from it. He stopped posting, disappeared from the system. Other users just rank 30 and kind of gradually drifts up. And there's a lot of rank dynamics going on. And I actually constructed a model that basically has a very simple model that uses rank, but actually uses the number of front page stories as a substitute for user rank. Oh, something's telling me I should be done. But anyways, I can construct a mathematical model that actually very accurately, qualitatively predicted the evolution of user rank on Dig. So these kind of systems, so nice thing about this, because these are so large-scale systems, each user is basically acting kind of independently based on kind of simple inputs from the friends. You can actually treat the systems mathematically and then study their behavior and, more importantly, optimize the collective behavior of the system with mathematical analysis. And if you ever come back, I'll just conclude my talk with some insights, because just saying that this is exciting to me as a, so actually, OK, thanks. So this is actually just quick. This is the actual user, what the number of front page stories, how it changed in time, and number of how social network grew. This is the actual user. This is predictions of the model. Actual user, predictions of the model. See this user stopped posting after some time, submitting new stories. And there's actually no free parameters, this model. Very simple model, but it explains a lot of the qualitative behavior of users and user rank on Dig. And okay, so just, this is, even though there's been some little bit of prior work in kind of using collaborative effects of people, like, for example, collaborative filtering, like Netflix and Amazon are finding products to recommend because other people have liked this kind of products, But that's all very good, but this actually offers you a lot more. This is a lot richer data set where you can actually add people, not just, you can give opinion on people and not just products or bits of information. You can annotate a lot of data. So in their everyday use of the websites, users are creating large quantity of data, which we can exploit to get all kinds of new information out. So I believe this actually does facilitate new ways of interacting with information. We can actually use other people to filter stuff out for us rather than doing it ourselves. And it leads to new solutions to old problems or maybe even new problems. And as I like to say, well, this is the Google approach versus the Yahoo approach, or how instead of constructing ever clever algorithms to solve problems, we can harness the power of collective intelligence to solve the similar problems. And one thing I just want to point out is basically, well, in the AI, semantic web was very popular, although now it's basically declared dead, but there was a lot of excitement when it was first introduced, because the idea was like you can take a web page or any kind of document, you can annotate it with some concepts, and then computer programs will be able to automatically access this data and use it to solve different types of problems for you. And this was really, like, people got it, really thought it was the next killer app for web. But then, as of right now, I think actually even Tim Berners-Lee kind of declared that it is indeed that. And the reason it died was because it was just too complicated. You couldn't get people to agree on the same formal semantic concepts for annotating things. It was too costly. You need specialized training. But the web, like the social web, offers another approach that will go towards solving the same problem. It's called taxonomy. So these tags I described before, you can look at those tags are also kind of informal classifications that many users are constructing. So if you look at not just a single user, but you look at large quantity of users and this little informal classification systems they have created, maybe you can actually extract some sort of taxonomy or classification system, and then use it to annotate documents to enable computers to interact and understand together. And like before, instead of connecting data, the web now connects people. And I do think it will lead to new applications and new solutions. And here I'm organizing, actually here I will find out, I'm organizing a symposium in social information processing. And it's going to take place in Stanford in March, a part of AAAI series. So especially I encourage people from the Mountain View to attend. I want to get some people from the industry to attend as well, because I think a lot of interesting stuff in this area is happening outside of academia, like in companies like Google and Yahoo and many others. Right, thank you.